All right, this is going to be our screencast going over the items on the Unit 5 test that refer to seasons. So that's TEKS Objective 8.7a for those of you who are interested. So I'll go through the test questions and then we'll kind of search and find the information that we need to answer it in Lesson 1, which is the one about seasons. All right, so question number 1 on your test says select the choice that does not have any significant effect on the Earth's seasons. And if you listened and took the notes like you were supposed to, one of the things that I made sure that you wrote down was that the distance from the sun does not determine seasons. Okay? The change in the distance as we revolve around the sun is so small that it is not enough to affect seasons here on Earth. So select the choice that does not have any significant effect on the Earth's seasons. That would be A, the distance the Earth is from the sun. The tilt of the Earth on its axis has a big effect, not only because it, let's see, you go over to this page in particular, and remember, it says that the tilt causes variation in the number of daylight hours, and tilt really is also causing a variation in how direct sunlight is because the Earth is spherical in shape, and you're going to have some areas tipped towards the sun receiving direct sunlight and areas that are sort of tipped away from the sun receiving less direct sunlight. Okay, question number 2 says 365 days is the approximate amount of time it takes the Earth to... Well, we're back to page 227. 365 days is the time for the Earth to complete a full revolution around the sun. So you should have answered G on number 2. Number 3, which of the following is not true about summer in the Northern Hemisphere? All right, the Northern Hemisphere, during summer, the Northern Hemisphere is going to be tipped most towards the sun. So for instance, this is on page 229, and it says during summer in the Northern Hemisphere. Okay, a person has already had many daylight hours by the time a person in the Southern Hemisphere reaches daylight. Okay, so you're going to have long days and short nights in the Northern Hemisphere during our summer, which is June, and the Southern Hemisphere would have just the opposite. So, which of the following is not true? Well, the Northern Hemisphere experiences long days and short nights. That answer is B. That's true. It begins on the June solstice. That's also true. That's A. The one that's not true is that the Southern Hemisphere experiences more direct sunlight. And you can see here that in June, we're experiencing more direct sunlight in the Northern Hemisphere, and the Southern Hemisphere is experiencing less direct sunlight. Okay. All right, number 4. At blank, the sun shines equally on the Northern and Southern Hemispheres. This means that each hemisphere has daylight for approximately how many hours? Okay. On page 230, it talks about your equinoxes and your solstices. Okay, an equinox, the sunlight shines equally on the northern and southern hemispheres. Okay, and during an equinox, everybody pretty much experiences 12 hours of daylight and 12 hours of darkness. Okay, so on number 4, the first blank should be at an equinox. The sun shines equally on both the northern and southern hemisphere. This means that each hemisphere has daylight for approximately 12 hours. So your answer on number 4 should be G. Number 5, which of the following is not true of the equator? Remember, the equator is the line that marks 0 degrees latitude. It separates the northern hemisphere from the southern hemisphere. Okay? Everybody at the equator pretty much receives 12 hours of sunlight every day of the year. It's the line that separates the northern hemisphere from the southern hemisphere. That's true. C would be the one that's not true. It has more seasonal variation than the poles. That is not correct. Do locations at the equator receive direct sunlight all year? Yes. Okay. Is it absolutely 90 degrees directly overhead every day of the year? No. But it's never all that far from 90 degrees at the equator. Okay. So the sun is always fairly high in the sky and you're having 12-hour days at the equator. Okay. And remember, let's see. Okay, my little camera has difficulty with dark and light on the same page. So for instance, this red arrow represents the equator. It separates the northern hemisphere from the southern hemisphere. Here it is again. Separates the northern hemisphere from the southern hemisphere. Over here in this diagram, this is the equator. Why isn't it horizontal, Miss Goff? Well, that's because, remember, the Earth is tilted on its axis, okay? The equator is perpendicular to that rotational axis that we talk about, okay? All right, again, here, this is the equator. This little imaginary line is the rotational axis. And of course, remember, we're tipped 23.5 degrees from straight up and down as we orbit the sun. Okay, so that does it for 1, 2, 3, 4, and 5. Let's go to number 6, and you should be on page 228 because this is very similar to what you had down here on page 228. Number 6, the spherical shape of the Earth affects how the sun warms up an area. Temperatures are higher at point A because the sun's rays are more direct. Okay, we had answered that when we did the notes. Which location on the illustration of the Earth below receives more direct rays? A. Okay, because it's shining directly. At B, the sunlight is more spread out because of that spherical shape of the Earth, and you have the sunlight coming in at a low angle there. Okay, so we need to say the rays are more direct at A, which is going to leave us with answer choice F or H. And then it's because the sun's rays are more concentrated. So that's going to leave us with F. Okay? All right, now we're going to talk about the December solstice. All of the following are true about the December solstice except. Okay, so let's think of December. For us here in the northern hemisphere, December solstice would mark the first day of winter for us. And remember, the first day of winter is going to be our shortest day of the year. But in the southern hemisphere, they're going to be having just the opposite. So in the southern hemisphere, the December solstice marks the first day of summer for them. So like people in Australia are having summertime in December and have Christmas, for instance, in the summertime. All right, so let's think about this. All of the following are true about the December solstice except, okay, it's the first day of winter in the northern hemisphere. That is true. Okay, the December solstice, which is about the 22nd of December, marks the official first day of winter, so that's true. It's the first day of summer in the southern hemisphere. That's also true. The northern hemisphere experiences less direct sunlight and short days. That's true. Okay. The South Pole has 24 hours of night. Okay. If you think about, let's see, this would be June. This is also June. So let's see if we can find one for December. Okay, so I know this thing has a little bit of trouble when it's that dark, but look over here. It's the northern hemisphere, the North Pole, that's tipped away, and you see that the North Pole never receives any sunlight at the December solstice, and it's the southern hemisphere's axis that's tipped more towards the sun. They're going to have 24 hours of day, not 24 hours of night. So the one that is not true, the one it says all the following are true except D. Okay. All right, let's go to number 8. It says use figure 1 to answer the following questions. Which position or positions mark the first day of fall in the northern hemisphere? Okay. So let's go to our paper. Hang on. Okay, so let's examine the diagram first. You have the dashed line representing the rotational axis. Okay, it's here, 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 here. In all cases, it's pointing in the same direction out into space. It always points towards Polaris. So if we look here, we notice that it's the southern hemisphere that's tipped more towards the sun. So this has got to be the first day of summer for the northern, sorry, did I say northern? The southern hemisphere, sorry. The southern hemisphere is tipped more towards the sun. The northern hemisphere is sort of tipped away. So this is going to be the northern hemisphere's first day of winter, southern hemisphere's first day of summer. Okay, and if you notice, you're going around in this direction, follow the arrows. If this is the first day of winter in the northern hemisphere, then in 3 months, this has to be the first day of spring because spring comes after winter for the northern hemisphere. Okay, then this has to be the first day of summer for the northern hemisphere, first day of fall for the northern hemisphere, first day of winter for the northern hemisphere. Okay, southern hemisphere, first day of summer. After summer comes fall for the southern hemisphere, then winter for the southern hemisphere, then spring for the southern hemisphere. So which position or positions mark the first day of fall in the northern hemisphere? Okay, remember this is winter, northern, spring in the northern, summer in the northern, so this one's fall in the northern. So that's answer G. Which position or positions mark the first day of winter in the northern hemisphere? Again, you want to find the position where the North Pole is tipped most away from the sun, so that's going to be position 3 right here. So that's answer C. Which position or positions will there be equal length of day and night for the southern hemisphere? Well, those are going to be on your equinoxes, and there are 2 equinoxes every year. You have your fall equinox and your spring equinox. Okay, so here this is the first day of winter for the northern hemisphere. This is the first day of spring for the northern hemisphere and the first day of fall for the southern hemisphere. But this is an equinox. Okay, first day of summer for the northern, winter for the southern. But this is another equinox. Okay, this is the first day of fall for the northern, spring for the southern hemisphere. So your equinoxes are here and here. That's 2 and 4. Okay, and it really didn't matter whether I asked about the southern hemisphere or the northern hemisphere because equal day and night are going to be happening all over the world on those 2 days, on the equinoxes. So number 10 is J. Okay, real quickly we have a similar diagram. It's just this time we must have been looking at the solar, looking at the solar system from like the opposite side versus what we were looking at this other diagram because the axis is pointing off this way. So Polaris must be this way for us. Okay, here it's the first day of summer for the northern hemisphere. So first day of fall for the northern hemisphere, first day of winter for the northern hemisphere, first day of spring for the northern hemisphere. Okay, first day of winter for the southern hemisphere, spring for the southern hemisphere, first day of summer for the southern hemisphere, first day of fall for the southern hemisphere. Okay, so which picture would be the longest day of the year for Lexington, Texas? Okay, well, you had to know that Lexington, Texas is located in the northern hemisphere. So longest day of the year goes with the first day of summer. So the first day of summer in the northern hemisphere is at position T, and that's going to be answer D for number 11. Which area marked would be the season of fall for Lexington, Texas? Okay, well, if this is the first day of summer at T, then this whole time, this is the season of summer. Then this is the first day of fall for the northern hemisphere, and this is the season of fall. So it's going to be Roman numeral 3, and that's answer H. In which picture does the South Pole get no sunlight? Well, it's when the South Pole is tipped away from the sun, and that's going to happen when we're tipped most towards the sun. So our first day of summer in the northern hemisphere corresponds with the southern hemisphere's first day of winter. And you notice